For this example, given that 1 over u plus 1 over v equals to 1 over f, with f as a constant, so look at the symbol given here. They said f is a constant. So if f equals to 10, and u decrease at the rate of 2 cm per second, find the rate of change of v when u equals to 40. When you read from this formula, if you notice that this is your length formula. So we are apply our physics with mathematics here. Okay, so as f is a constant means the other variable we can see the u and v will be variable. Okay, then they say u decrease at the rate of 2 cm per second. So our first step. So for this question we don't have shape. We are given formula straight away. Then we only identify the variable that we have. So the changing variable u decrease. So du dt, the rate of change of u, is equals to 2 cm per second. And is it decreasing? So this derivative form should be written in negative sign. So this is our changing variable. Find the rate of change of v. So we need to find dv dt. So this is going to figure out when u is equals to 40 and f is equals to 10. So f is a constant. As we can see, f is a constant and u equals to 40. So this is the constant we want to substitute when we want to finding the rate of change of v later. Then we can go to step number 2. We finding the chain rule that we need as dv dt. If we want dv dt, so means we can start with dv and then ending with dt. So look at the variable that we can link here. V only can link with u for this formula. As f is a constant, so the variable here only u and v, and we have du dt. So dv will link to du, differentiate v with respect to u, and then continue du dt so that we can get dv dt. And we can notice here du dt is given, so we need to find out step number 3. Figure out this. Find the equation v in terms of u. So since the equation is given, so we no need to find. We use the equation given here. As f is a constant and f is already given 1 over 10 means this is 1 over 10. So we can substitute the constant. This is 0.1. So this is the equation that we should have. And we want to differentiate v with respect to u. Look at the equations here. So step 3 is finding the equation in a single variable. Yes, v and u only. You can see this equation is in v and u, but this is not explicit. As we can see our equation u and v operation together. So this is implicit. So we can differentiate this one implicitly. So differentiate v with respect to u. So let's observe here. This is the objective we want. So differentiate v with respect to u. Before we start differentiation, we rewrite this in power. Differentiate v with respect to u. So power move to the front, then power minus 1. So this is respected u. Then for v, so we're doing this differentiation implicitly. Power move to the front, power minus 1. Because of v, implicit differentiation, dv du. So lastly, we find out what is our dv du here. And we differentiate from the right hand side, constant, we get 0. So move this one will be 1 over u squared. So lastly, we obtain dv du equals to negative v squared over u squared. So step 3, we obtain all the differential equation. Then step 4. So step 4, we're going to substitute everything back to our chain rule. So you can see dv dt, dv du is obtained negative v squared over u squared. And du dt is the information that we get earlier in the questions, which is negative 2. And then lastly, we substitute v and u. So what is the changes happen at this v and u? When u is 40, what is our v? So this is we need to figure out. Find out this unknown here. So using the original equation, when u is equals to 40, original equation 1 over 40 plus 1 over v equals to 1 over 10. So 1 over b will equals to 3 minus 3 over 40. So inverse it, v 40 over 3. Then lastly, we substitute back to our differential equation here, differential equation or chain rule here. Negative 40 over 3 square over 40 square times negative 2. So V unit cm, time units here is using second, cm per second. So this derivative form is positive. We can say that the rate of change of V is increased by 2 over 9 cm per second.